Good morning, my name is Shah Patidar. In this video, we will cover the logic gates can be built using single layer neural network. So first of all, we will perform the operation on the AND gate, OR gate, NOT gate and NAND gate. So here to perform it, first we require our sigmoid function. So our sigmoid function is 1 upon 1 plus e raised to power minus z, where to calculate the z, we have this formula where W is weight 1 and X1 is input 1 plus W2 is weight 2 and X2 is input 2 plus the bias factor. So for n get, we had taken weight 1 as 1, weight 2 as 1 and the bias factor as minus 1.5. And our input are 0, 0, 0, 1, 1, 0 and the 1, 1. When we substitute these values with the help of our weight and the bias factor into this equation, then we get our output, then we get our sum as minus 1.5, minus 0.5, minus 0.5 and 0.5. When we substitute this sum into our sigmoid function is 1 upon 1 plus e raised to power minus z. So we get our desired output as 0, 0, 0 and the 1. And when we create our normal AND gate table using the dot operator between the inputs, so that table and this table, both the table get matched, so our result matches the AND gate. Now for OR gate, our weight factor is 1. For weight 1, for weight 2, our weight is 1 and our bias factor is minus 0.5. When we substitute these values into our function, into this equation, then we get sum as this. Then we substitute this sum into our sigmoid function and then we get our output as 0, 1, 1, 1. So here when we perform our normal operation into this normal operation on the table, then we get the same desired output and this output both of them get matched. So this output matches our OR gate. The NOT gate chooses the weight equivalent to minus 1 and the bias factor as 0.5. When we apply this into our equation, so we get output as 1 and 0. As we know that if it is 1, then NOT gate will give as output as 0. And when input is 0, then the NOT gate will give us 1. Now the last one is the NAND gate. In NAND gate we have weight 1 equivalent to minus 1 and weight 2 equivalent to minus 1, where bias factor is equals to minus 1.5. When we substitute into this with the help of our input data, so we get the following sum. Now when we substitute this sum into our sigmoid function is 1 upon 1 plus e raised to power minus z. So we get the following output. So here our NAND gate matches. Here now we see our table consists of different gate. Here the weight, bias factor and the single layer implementation. All of these gate have single layer implementation. So here we had written yes. Here in the weight block we had written the weight which we already assigned them and performed the operation. And in the bias factor also we had already assigned to them. So we had placed our bias factor into the table. Thank you.